In this video, we're going to continue our discussion of linked lists. We talked in the last video about the general idea of a linked list, what it does, looked at some representations of it, and so what some of the code could look like. So in this video, we're going to continue on talking about how to add new nodes to a list. I think in the last video, we added a node just to the head node, okay? But there's a little bit more going on, okay? So when we're adding a new node, we have some options. The um, the first option is that as we're adding new nodes to our list, we can just go ahead and add them to the end of the list every time, okay? So if we only have one node, easy enough, then we have to just add it to the head link becomes the new node. But if we have more than that, we have to find where the end is. So we'll go through that in a second. The other thing that we can do, we can add all nodes to the beginning. And that's probably the easiest in some ways, in that we always know where the head is. So we just add one before the head. There's a risk here that you lose your head or lose the rest of the list. So we'll talk about how we can take some steps to avoid that. And then third, you can do some kind of custom things. You can sort them, you can insert them in a particular order. And we won't talk about that today, but we will at some point. Okay, so we're going to talk about the first ones here. So if we're going to add a new node to the end of a list, okay, so, and I've got this incorrect because I had to change that. So we're going to create our new node first. Okay. And then step two is going to be to find the last node. Okay. So we have to modify this. We're going to find the last node. How do we know it's the last node? It's where we're going to use a pointer here where P link is equal to null. That's how we'll know we're at the end. Okay. And then we'll just set that P link equal to the new node we've created. Okay. Then we're going to delete the new node, or we can delete them all at the end, and that should be okay. That's adding at the end. We'll go into more detail. But then the steps to add to the beginning, we're going to create the new node, assign its values as always. We're going to set the new node link equal to head, so equal to the existing list. Okay. We're then going to set head to point to the new node. If we just set head to point to the new node right away, then we would not be able to recover where the rest of those nodes are. Okay. And then we'll delete everything at the end. Okay. So just to, I want to do a picture here to define what we're doing with these ads. But let's start here, just a review of the basics for us. We're going to use a struct to create each node. Okay. Again, we could use a class for this, but we're keeping it simple with a struct. It just has an int info, could be whatever you want, could be a double, could be a string. We're doing integers. And then we have a node type pointer called link. Okay. So we're then going to declare variables here for the head, the new node, and P. These are pointers to node types, hence the asterisk there. And then when we create our new node, we just do new node is equal to new node type. We've declared new node here as node type. We're making it a new one here. And this is why we need to delete it later. Whenever you allocate memory with new, you need to deallocate it with a delete eventually. Okay. And once we have our new node, we're going to set the info equal to 5, and the new links is equal to a null pointer, which points to nothing. Okay. So we can then set the head pointer equal to this new node. That's our list. Okay. At that point, we could delete the new node. Should be okay. Actually, we don't want to delete the new node. Not yet. Okay. So if we want to add this new node to the end of the list, so let's switch over here for a second. Let me share this picture here. I'd like to be able to draw this on a board, but I don't have that option. So if we're going to represent this as our node, which is the way I tend to do it, I think the book has it flipped around horizontal instead of vertical. But the idea is the info is in this top part, and then here's the pointer. Okay. So in the above example, we create a new node. So here's my new node pointer. I'm going to move it up into position. Okay. This new node pointer is going to point to this node. I don't like where that's going, but you get the idea. It's pointing up here. Okay, new node points there. Don't need that. Okay, so we can set the values. If we put a 5 in there, and then that is a null, which we normally denote like that, backslash. Okay, so to make our list, we're going to take our head node, or the head pointer, sorry. And we're going to point it also to this first node, okay? So that's what we've done after the first one, okay? So to go over the idea of if we're going to add a second node, okay? So I've just got some little guys over here. So we're now going to create our new node here. Put it wherever you want. It doesn't really live there. We're going to initialize it with, let's say, 10. Okay. And then new node now points to here. Okay. So in order to add this to the end, we first have to make sure we're at the end. We're at the end because the link is equal to this to null. Okay. Going to get rid of that. And then I'm going to point this to this node. Okay. And once I've done that, I don't care about that anymore. And I've already set that. I didn't do it here, but I've set that equal to null. Okay. So that's what it looks like after we add one. Okay. Now, if we go to add a second one, okay, so I'm going to grab another linked list node over here. I'm going to set it equal to 25, let's say. I'm going to have a backslash there. These are in numerical order, but there's nothing that says that they have to be, just how I'm doing them. Okay. So now our new node pointer is going just to point up here, doesn't matter where. Okay. So in order to make this new node part of the list, I'm going to have to make sure I'm at the end. And I'm going to do that with this p pointer. You can call it whatever variable you want, but p is what's commonly used. Or I can move it. Okay. And I'm going to start by putting p to head. Okay. I'm then going to check and see, does p link equal to null? And it doesn't. Okay. So I'm going to set p, which points here, to p link. Okay. When I do that, p is now going to point to this one. Okay. I can now say, does p link equal to null? And p link does equal to null. Okay. So all I have to do now is point p link. So this value here will now point to the new node. Okay. So when I do that, we usually draw it like that, and that points there. Okay. And then again, we don't have to worry about that. Don't have to worry about that. So now we've added on to the end. Okay. We can keep doing that as much as we want. And we also talked before about printing, but the printing works in a similar way. You set P to the first one, you print out the info. As long as P link is not equal to null, you go to the next one and the next one and so forth. Okay. So let's take a look at that code. I was going to create this code live on the video, but I was afraid that was going to really take forever. And I'm trying to keep this from being a 35,000 minute video. Okay. So this is what we had before, where we've created our first node. Okay. And then we've created a second node here. Now note that I'm using the same new node. I'm able to reuse this. New node is a look how we declare it here. New node is a pointer to a new node type. Okay. So we're going to, when we say new here, we're allocating new memory for it. Okay. So this doesn't affect at all the node with info 5 we just set. Okay. So this one we're going to set it equal to 10, and we're setting our link equal to the null pointer. Okay. We now have to go, as I showed before on the graph, we have to set p equal to head. And as long as p link is not equal to null pointer, we're going to keep moving. And we move forward in a linked list by setting p. P points to some node. P link is also a node pointer. So if we set p equal to p link, we go to the next link in the list. Okay. So we keep doing that. When we're done, p is pointing to the last node. So we can set p link equal to this new node. Okay. That way we've placed the new node into the list. And then in this code, I'm just printing it out to see where we're at. Okay. Here I'm adding another one. So this time I'm going to do a new node with the info of 25. Okay. And again, doing the same exact thing. You can see that all this searching and entering and the printing is pretty redundant. I'm having to do the same code over and over. So clearly we're in need of some functions, but we'll talk about that a separate video on how to smooth that out a little bit. Okay. So because they are memory variables, we have to think about how we're going to be able to pass things back and forth. Okay, so we're now printing out through that, we're iterating through the list and all that. Okay, so that's how that's going to work. So now let's look at the idea if we wanted to add a new node to the beginning of the list. Okay, so we create a new node from my little stockpile of pre-made new nodes. Let's say we're going to add it right here. Okay, it's going to have a 1. Again, I'm keeping them in order, but they don't need to be. It's going to have that. Okay, and new node is now going to point to this node. Okay. So again, if we were to just take this head node and point it, that's not what I wanted, the head node and point it to here. 1 becomes the first item, but all of these are lost in space. There's no way to get to them. Okay. So that's not what we can do yet. Okay. So to stop that from happening, we first have to set the pointer on our new node equal to head. So it is going to point here as well. Okay. Now that it points there, then we don't have a problem in changing the head pointer to point to there. Okay. And again, doing these little kinds of graphs on paper are super helpful when trying to figure out where the pointers need to go. Okay. So again, to print this one out, we would set P equal to head. Okay. P info is equal to 1. If we set P is equal to P link, P now points here. P info is now 5. Print that out. P is equal to P link as long as it's not null. Going to go here. It's going to print the 10. It's not null, so P is equal to P link. Go to here. P info is now 25. P is equal to, sorry, if P is not null, P is null, so we stop. Okay, that's how that works basically. So let's go back and look at that code. Okay, we're going to add one at the beginning. So again, I've set up a new node with the type, with the info of 1 and the null pointer. Okay. So the first thing I have to do here, I have to set my new node link. And I guess I didn't need to set it equal to null pointer here, but it doesn't matter. I can set my new node link equal to head. So this is going to be the head of the list and whatever it has. Okay, remember these are like treasure maps. As long as you can get to the first node knows how to get to the second node and the third node and so forth. But again, remember, unlike an array, we don't know how long our list is unless we keep that somewhere in a variable. And there's no way to directly get to the 5th element or the 10th element or whatever. We have to start at the beginning, go all the way through. Okay. So once I've set this new node link equal to head, I can then reassign head equal to the new node. Okay. And now I'm going to print out the list again. So that's all that this does. Let's take a look at this. Okay, so if I compile it, and I'm doing the cheap don't give it a name. You should not do that. You should give it a executable file. When I run it, you see that we start. The first time we have the list, we have the 5 and the 10. Okay. Then we add the 25 at the end. We have the 5, the 10, 25. Looks okay. Then we're going to add at the beginning the 1. Okay. So 1, 5, 10, 25. It all looks good. Okay. Now, one thing to keep in mind, if you ever need to have more than one list at a time in your program, the list name here is head, okay, because we use that with just one list. You could certainly call that list 1. You could call it A, you could call it whatever you want. But I would probably do something like list 1 head just to make sure that you know what's happening there. Okay. So we still have to worry about deleting nodes. We have some other things to keep track of on our nodes, but I think that's it for this video to try to keep it kind of modular. Again, the book has a lot of details, a lot of examples. This is just one that I kind of made up. And again, here at the very end, what I'm going to do when I get down there is make sure I delete all of the pointer, all the node type pointers that I allocated, I have to delete. Okay. So I think that makes the most sense. I'm not sure that I really need to do head or P because I don't think those are ever on a line that has a new keyword, but it certainly doesn't hurt to do that. Okay. So that's part 2 of linked list. There will be a part 3 where we'll cover the rest of things. Okay. So if you have any other questions, make sure that you let me know. And now I have to find on the new Zoom where to stop the recording. Here we go. I'm going to stop it now.